Hello and happy Friday. Um, Hopefully at this point you guys have had a chance, like 6 or 7 minutes or so, to look at numbers 1 through 8 on page 287. If you have not had that opportunity yet, let's go ahead and give this video a pause. Try those 8 on your own first, and then we'll go ahead and go over them together. But hopefully at this point you've had a chance to look at these 8. This was from 10.2. So I know we learned 10.3 yesterday. We're going to go back a couple of days back to Wednesday and look over 10.2 one more time. So these 8 shouldn't have been that bad. It says, I'm going to minimize this. Identify the given arc as a major arc, minor arc, or semicircle, then find the measure of the arc. Now, I typically do that in the reverse order. Like, I find the measure first and then decide if it's one of those. But however you want to do it is fine. So we're going to start off here with arc AB. Now, that's 2 letters, so it should be a minor arc. And so if we look at that in the picture, we're going to start here at A. And we're looking at the arc from A to B. And how big would that be? Well, it's going to be really important that you read this right here. Okay? You're not going to be able to do this problem if you don't read that. So that right there says that AC, that diameter through the middle, is perpendicular to BE. What does perpendicular mean? Think that in your head. What does perpendicular mean? How do those lines have to intersect? And the answer is they have to intersect at a right angle. So if those lines are perpendicular, that right there has to be a right angle, which is going to help us for the rest of the problem. And also, I should say that this is also going to be a right angle if those lines are perpendicular. So if that's a right angle, that central angle, AEB, is 90 degrees, then arc AB would also be 90 degrees. And what type of arc would that be? That would be a minor arc because it is less than 180 degrees. Okay. Number 2 says arc ABC. Remember, you have to go in that order. Start at A, go through B, connect all the way to C. That would be this arc right here. Okay. Hopefully this one was a little more obvious. AC is a diameter going straight through the center. So that ABC is going to be a semicircle, which is 180 degrees. Okay. ABD. A all the way through B, all the way over to D. It wouldn't go the other direction because it has 3 letters, and it has to cut through B. ABD. Now, that ABD is just ABC with one more little section added onto it, this 40 degrees. So if ABC was 180, and then this little CD is 40, then 180 plus 40 is 220. And that's an example of a major arc. I'm going to go back and do some erasing here just to re-look at some stuff. The next arc is arc B to C. B to C. B to C, that central angle is 90 degrees, so arc BC would also be 90 degrees. And that would again be a minor arc. BAC, BAC, that's a big arc here. It starts at B, goes through A, and circles all the way back around to C. Okay? Starts at B, goes through A, circles all the way back around to C. So that big old blue arc right there. Should be a pretty big number. If the green arc, BC, is 90 degrees, and you think about what a full circle is 360. So to find the rest of that circle, we would just take 360 minus the 90 to get 270, which is a major arc. And it's very possible that there's more than one way to find these, just so you know. This is just how my brain is working. DAB, dab. Start at D, go through A, all the way around to B. So again, there's a couple of different ways to find this one. Some of you might have chosen to find the arc DA. So like you could take 180 minus 40 to find DA and then add it to that 90 degrees. Or if it were me, I know that this right here from B to D is 90 plus 40, which is 130. So to find the rest of the circle, I would just take 360 minus 130, which is 230 degrees, and is a major arc. But logically, that's not the only way to solve for that one. You could have found the DA, like I said, so 180 minus 40, and then just add that to 90. Okay, a couple more here. Oh, there you go, AD. This one right here, A to D. Actually, no, let me erase some of this stuff again. It gets a little confusing when I got too much going on. A to D. A couple different ways to find that. Here's how I would look at it. This right here, diameter, is cutting the circle in half. So half of a circle is 180. This little portion of it is 40. So 180 minus 40 is 140 degrees, which is a minor arc. Now again, guys, when you highlight the arc, if it is less than half the circle, you know your answer has to be less than 180. So that should always be a point that you keep in your head when you do these problems. And then CD, the last one. Oh, this one's not bad at all. I'm going to erase all this. CD, this one here, 40 degrees, which is going to be a minor arc. Okay. Hopefully you copied all this down. We're going to do just a couple more problems here. Hopefully all 8 of those are copied. Okay, I'd love for you to flip open to page 292 now. So go a little bit further. We're just going to do a couple of these problems, mostly because these will be on your quiz on Monday or Tuesday, depending. Monday, I believe, is the even periods, and then, of course, also 5th hour. And then Tuesday will be all the odd periods. So depending on when you have your quiz, but this will be on your quiz. So 7 and 8 real quick. You guys learned a theorem yesterday that said if you have a radius in a circle, now they only ever show you like a piece of the radius. So like PE is a piece of your radius. But we learned a theorem that said if that radius is perpendicular to a chord, then it splits that chord in half. So like DF right now is being split into 2 equal halves. DE is 1/2 and then EF is the other half. Okay, and then same thing on the other side. BP is splitting AC in half. Okay, and it has to be perpendicular. That's the key. Now that doesn't necessarily mean that, oh yes it does actually, sorry. And we also learned yesterday that AC and FD are congruent to each other. So pretend I put 1 tick mark there. Okay, so a couple different scenarios here. First thing you should do is solve for x in either case. First thing you have to do is solve for x. Our goal here, if you look at the directions, is to find the radius. Oh, where'd my eraser go? Oops. Find the radius. That's our goal here. Okay, first thing we have to do is solve for x in either case. So on number 7, we know that AC and FD are equal to each other. So we're going to go ahead and set those two expressions equal and solve. So minus the 3x, you get 2x minus 2 equals 2. I'll pause for a second so that those of you still writing can write that down. Add the 2 over, and we get 2x equals 4. divide by 2, and we get x equals 1. Okay, that's like step number 1. Step number 2, because if you remember from yesterday, we're going to end up drawing in a little right triangle. We need to find the length, and I'm just going to pick one of these red chords. We need to find the length of this piece right here, because what we're going to end up doing is creating a right triangle where P to D is your radius that you're looking for. Okay, so we're going to use Pythagorean theorem in a second, but we first need to find the length of ED. So let's go ahead and take that 1 and plug it in. And it shouldn't necessarily matter which one you plug it into, but I'm just going to go ahead and plug it in on the one that I'm looking at. 3 plus 2 is 5. I feel like I've done something wrong here. I'm looking 5x minus 2 equals 3x plus 2, right? Minus 3x. You get 2x minus 2, add the 2 over, you get 4. Oh, goodness gracious. You guys, go back. Sorry. I can divide properly. 4 divided by 2 is 2, not 1. Oh my gosh. You want to know how I knew I was wrong? Because when I plugged x in, I wasn't getting the same answer on both sides. Whoops. Okay, now we should be in business. So sorry. I mean, it wouldn't be a day in the life of geometry if Miss Kelly didn't make a mistake. So there you go. There's my mistake, even when I'm gone. So now we're going to take the 2 and plug it in. Now it works out. 3 times 2 is 6, plus 4 is 10. Okay, which is what I would have gotten. No, I didn't get it up there either. Hold on a second. Let me figure this out. Okay, I'm back. Wow, what a morning. P.S. I'm recording this at 7 in the morning, Thursday morning. Oh, goodness. Okay, that is not a 4. That's a 2. 6 plus 2 is 8. Oh my gosh. Okay, I finally got there. Holy moly. Okay, now, the 8 is this entire thing, D to F. I only want to use D to E because I want to draw this little right triangle. So what would I need to do with that 8 is cut it in half, which would make D to E 4. And now you're looking at a little right triangle where this is 3, this is 4, and you're looking for the hypotenuse, which is going to end up being the radius. Because remember, your radius is any segment that goes from the center to a point on the circle. So P to D would be an example of a radius here. And so final step is to use Pythagorean theorem. 3 squared plus 4 squared equals r squared. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, that's r squared. Square root, and we get r equals 5 as your final answer for the radius. That was rough, you guys. Okay. Cool. We're going to do the same thing on number 8, but now your algebraic expressions, the stuff with x in it, are no longer on the chords of the circle. Now they're on those little pieces of the radius. Now, OZ and YO are not the radius itself, but it's a piece of your radius that we're going to use to find the radius. So again, if that piece of the radius is perpendicular to the chord, those have to be the same. So step 1 here, we're going to go ahead and set them equal and solve for x. Hopefully I don't mess up as badly as I did last time. Minus the x over, we get 3x minus 5 equals 4. Add 5, and we get 3x equals 9. Right? I'm not messing up here. Divide by 3, and I'm getting x equals 3. And as I look up there, when I plug it in, I get 7 for each, so I know I'm good there. Okay, x is 3. Now again, I'm going to end up drawing in like a little right triangle here, where I need to solve for the radius, that hypotenuse. Okay? If I plug in x, if I plug in this 3 right here into x plus 4, I get this being 7. Okay, I don't know the hypotenuse, that's always going to be the radius. The radius that you're looking for in a problem like this will always be the hypotenuse of the right triangle. Now, this here, z to x, remember, is not the full 20 because x all the way across is 20, so z to x would be half of that, which is 10. And then we're looking for the radius. So we're looking at a right triangle that looks something like this, where this is 7 and this is 10, and I'm looking for the radius. Okay, Pythagorean theorem. 7 squared plus 10 squared equals r squared. 7 squared is 49. 10 squared is 100. 100 plus 49 is 149. Get out my calculator. We're going to go ahead and say decimals for now are fine. Square root of 149 is 12.2 approximately for your radius. If you want to leave it exact and break down the radical or leave it as radical 149, that's fine as well. Okay. Holy smokes. That first one was rough. I apologize. So there's those 2 problems here. Those are going to help you for your quiz review today, because now at this point what I want you guys to work on is the gold quiz review. Okay, that'll be due Monday or Tuesday, whichever day you have class. It is a block schedule, so on Monday or Tuesday we'll have some time to go over it before your quiz. That'll be nice. We won't be losing any time there. But at this point, make sure you are trying to get the entire quiz review done. I don't want to use Monday and Tuesday as a work day because I want to make sure you get that quiz totally completed on Monday and Tuesday. Okay? Okay. There you are. Have a fabulous weekend. If there's any sporting events, good luck, or club events, have fun, good luck. And I will see you all on Monday or Tuesday. Have a good weekend.